Hey, Miss Marion here. So we're doing Unit 1, Lesson 3. And so we're going to go ahead and go through those. Make sure you have your Unit 1 workbook, which is green. And we're going to go ahead and go through Lesson 3. All right, let's turn to page 21 just to kind of get us started. You're going to write down which one doesn't belong, A, B, C, D, or E. Write a sentence. Notice how we have this sentence frame for you. Expression blank doesn't belong because blank. And go ahead and fill that out all the way. So am I looking for a particular answer? No, I'm not. It's just more getting our mind kind of looking at different things. I'm going to say D doesn't belong because all the other ones have 2 in it somewhere, and D doesn't. But you can talk about any of those, and it's not a particular answer. It's just more getting our brains thinking about these kind of expressions, and it's expression because it does not have an equal sign in the stuff. So today we're going to be figuring out how we can label a diagram to see the pattern. We're going to be looking at mathematical representations that also show patterns. Yesterday we did patterns. Today we're going to also be looking at patterns again. Also on page 21, we have these pictures. So we're also going to write down what do we notice and what do we wonder. So I notice that, and then I wonder. So go ahead and take a second, write down your 2 sentences. Yes, there should be sentences on page 21 about these 2 different kind of things. So personally, I noticed that everything kind of doubles itself. And then I also kind of wonder, why are we looking at this? What are we looking at? What kind of makes us want to go ahead and go through this? So looking at the same pattern, what I want you to do is go ahead and describe and label a pattern that you see on page 21 with all these different dots. So go ahead and write down underneath here as far as the pattern that you see. So this is one way you can actually kind of look at it. This is what is called T sub 0. This is the beginning. And then this is after 1 time frame. So notice how it kind of adds an extra on the triangles. This is the 2nd time frame. So it kind of adds more along with it. So we can also look at this as here's a triangle, here's a double triangle, and then here's extra pieces that kind of go along with it. And so what I like to do, we all know I like to go ahead and make tables out of things. Let's make a table with this. So I'm going to make a table. We have time, and I'm going to say number of dots. So at time 0, we have 3 dots. At time 1, we have 6 dots. Time 2, we have 12. Times 3, we have 24. Times 4, we have 48. So notice how we kind of keep on doing it. So is this a pattern through addition? Not really. Notice how if I take these and I multiply it by 2, so 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So notice this is kind of a multiple kind of thing. So it's not what we did in 8th grade, so it's a little bit different. And so we're going to kind of look at these multiples as far as what kind of goes along with it. All right, so let's look at number 2. It says, assume the sequence continues in the same way. How many dots are there at 5 minutes? So we kind of made our table. Here's my table, right? And what would it be at 5 minutes? So go ahead and answer that question and then come back to me. So remember the pattern is we're going to go ahead and we're going to take the previous number and we're going to multiply it by 2. So if I go 48 times 2, we're going to have 96 dots. So we're going to look at these 2 different ways. We're going to kind of think about it as like recursive as far as what we did before. And then we're also going to kind of think about it as like what is called explicit thinking. So recursive. Recursive is what we did before. And remember this bottom one has 96 dots. And so think about how would you go ahead and write this recursively. So go ahead, think about it for a second, write it down, and then come back to me. So remember, with recursive, we have to have a starting point. So where are we going to start? We're starting at x of 0. X of 0, where did we start? Where did we start on our table? That was 3. Or where did we start with our dots? We have 3 dots. And then, again, recursive kind of starts with the one before. What did we do with the 3 to get to the second piece? So if we have it as, we're going to write it as x of n, that's our next, or a certain number, or number of time frame. And we took the one before, so n minus 1, take the one before, and we're going to multiply it by 2. So this is the recursive thinking, where we have our initial point, and then we're doing something with it to make kind of like that final piece. All right, so now we're going to kind of think about it as explicitly. So we're looking at, we have a table. We also have kind of like a graph. Now we want to kind of think about the explicit pieces of information. And so think about it for a second. How would it explicitly go as far as writing these pieces? So go ahead and think about it for a second and then come back to me. All right, thinking about the explicit part, we are going to look at it and we're going to kind of write it as a function. So we have a function of t. That's our time frame. We started with the 3, and we're going to multiply it by 2 to the t power. So if you think about it, if we're doing it as one time frame, we're taking 3 and we're going to multiply it by 1t. So 3 times 2. And remember, the explicit equations, they don't work on the one previous. They work on what you start with and what you want your end result. So it's kind of like we look at it and we take it and we go, okay, we're going to take 3, we're going to multiply it by 2. And how do we do from the 6 without looking at the previous one? If we're trying to get like at time 2, how do we get the 12? We're going to take 3 and we're going to multiply it by 2 times 2. So notice I have 2 2's. And how do we get time 3? Well, I'm going to take 3 and I'm going to multiply it by 3 t's. And then how do we get time 4? We're going to take 3 and we're going to multiply it 4 2's. So notice how we have it as we take that original amount and then we're going to multiply it by, at that certain time frame, that amount, a number of 2's. So that's the reason why we have our explicit thinking as f of t equals 3 times 2 to the t power. So again, this is kind of puts everything together. So here is our table. Notice how we're taking 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. This is the recursive, where we look at the one before, what are we doing previous? And then this is also a thought process as far as the explicit. So explicit starts at the beginning, and then what are you doing with it to get to that specific time frame, not with looking at the one that's prior to it. So this would be the explicit. So again, here's our picture of our time 0, time 1, times 2. And again, I'm taking that 3, and then I'm multiplying it by 2 to get that time frame that goes along with it. So before was recursive, this one is explicit. So if we think about it as far as when we've done graphing before in 8th grade core, right? We take it and we were always doing a y equals mx plus b kind of line. And what this made was a linear relationship which also made a straight line. If we think about our explicit 1. We have our f of t, or we could write it as y. We took 3 and we multiplied by 2 to the raised to the t power. So whatever, if I put 2 in there, then we're going to bring it to the second power. If we put 3 in there, we're going to bring it to the third power. Notice how having these exponents actually makes our line curvy. So y equals mx plus b makes straight lines. That was last year. This year, we're going to be comparing straight lines with the curvy lines. And the way that we get the curvy lines is we have that exponential power. And that's what makes it curved. And if you look at the table, notice how it kind of jumps. It goes from 3 to 6 to 12 to 24. So it really jumps a lot, and that's why it doesn't make it a straight line. It makes it that curvy line. And then this is what is called a geometric sequence. Geometric makes it so it's curvy, and then we have linear relationship, which makes it straight. So go ahead and turn to page 23. Here is your takeaways. So go ahead and pause this right now. Go ahead and write this down underneath your takeaways so you can use it for your quiz and your test. So you're going to go ahead and check your understanding. So you're going to do your ready, set, go in Canvas. Make sure you go ahead and go through those. And there you go. Hope you have a good day. Thanks. Bye.